Hi guys, it's time for our next exclusive video lesson. People chose clean code best practices, so this tutorial will be all about that. I'm going to cover everything which is included in the official clean code book, but I'm not saying that you don't have to read it after you watch this video, but I'm going to cover all the concepts, all the main ideas which are included in the book. So if you don't have enough time, or if you think that you grasp the whole concept, you may skip reading it. But if you decide to learn more, or if you decide to get more details, you may purchase it. So I've prepared a short presentation just to give us clues for what we search for when we're talking about clean code, but most of the video will be in Visual Studio. I have downloaded the official Microsoft project which is used for their end-to-end testing, and it's not written with best practices in mind. I'm going to say as a disclaimer that we don't want to review Microsoft's code, or we don't want to point their mistakes, because this project is not written with best practices in mind. If we go to their GitHub, which is on their ASP.NET official repository, if we go to source, the music store application is there. Here it is. I downloaded that and I introduced a lot of tests to make sure that whatever we refactor is still working after the changes. So they say that this is a test application and it's used for ASP.NET Core internal purposes. It's not intended to be a representative sample of how to use ASP.NET Core. This is why there are a lot of mistakes in terms of clean code in the application itself, because a lot of things are not written the correct way, but I believe it's because they want to test different features of the ASP.NET Core framework with this application, and this is why it's so badly written in some places. You will see in a minute. So we don't want to blame Microsoft, but this is a superb example of how not to write clean code. So what's clean code all about? Clean code starts with what most people understand, what most people know, and that's naming and formatting. Most people know how to name their variables, how to name their classes, modules, functions, methods, everything. They know how to format the code, where to put the curly brackets, for example. This is the general knowledge. Yeah, that's important. It's super important to have meaningful names, and it's super important to have code that you don't need to document or comment for other people to understand. But most of the times I see tutorials online about clean code, it's usually in super small projects. Usually it's about very isolated cases. This is why I decided to use a developed project, because this application is not huge but has some functionality. It has listings of albums, it has a shopping cart, for example, which is written very badly. It has a store, checkout accounts, users, and so on. So this will be a perfect example of a real life project using clean code, or rather not using it. Additionally, I'm going to record 2 more videos about clean code and solid, and I'm going to use a project which is developed for more than 5 years now. So stay tuned for that, but let's start with the smaller one to grasp the initial concepts. So besides naming and formatting, which most people understand, we need to talk about the responsibilities and the boundaries of our code. When I'm talking about code, I'm talking about variables, functions, classes, and modules. In terms of C#, functions are methods and modules are actually projects. This is one module and this is another module. Uh, Most people understand that variables and functions need to be small, need to be as cohesive as possible. You don't see developers often make a mistake about a variable. They don't use a variable multiple times in their code, then they don't use a variable for different purposes. Most people understand that, for example, a variable age never stores information about variable decimal. People understand that they should not mix responsibilities for variables. But when we go to functions or classes or modules, it gets trickier because a lot more code is involved. And it's more difficult to understand what a single function do and what a single function needs to do. Uh, a lot of people start to write more bloated codes, a class which has a lot of lines, a function which does a lot of things. And with this particular example, the Music Store web application, I'm going to show you a lot of the code smells which are commonly mistaken by developers. Most of the code smells, there are a lot, more than 50. You may go to this site if you want to have more details, but I've written here the most common uh, examples of code smells which you will find in your code too, in my code too. People do code smells all the time. It's not because they lack the knowledge, it's not because I lack the knowledge, it's mainly because we're in a hurry, or mainly because we don't think about responsibilities of the different functions, different classes, or different parts of our code. We usually think about how to make the code work correctly and how to make the code start, compile, run, how to make the code uh, to not have any bugs, but we don't often think about, okay, let's think for solid. Let's think whether this code has a single responsibility. Let's think if I have to change this piece of code right here in the near future, will it be easy for me? If I need to add a new feature, if I need to fix a bug, what will happen? People don't think about these things, and we should as developers. We always need to think for the future, but not the very distant future. Not to over-engineer, over-complicate stuff. But we need to think, okay, the business has been growing rapidly during the last few months. So I expect that they will add this functionality and this functionality. Uh, Even better, you will have a board planning. You will have a planning board, and you will know what's coming up next. And you will know that most probably this business logic will need another functionality in the near future. And this is where we need to think about, okay, am I following, for example, the open close principle? Is this code easier to test? Is this code easier to change? And when I'm talking about tests, even if you don't write tests, it's a good idea to make your code testable. Because if your code is testable, it means that it follows best practices. It follows clean code, it follows solid, and it's generally better written because it will be easy to change functionality, it will be easy to remove some old stuff, it will be easy to fix bugs, and so on. So when we think about our code, we need to think whether it's testable enough, whether it's having a single purpose, and whether it will be easy to change in the future. I have a very good tutorial on testable code on my YouTube channel. So if you haven't watched it, I suggest you do because it's a practical approach to what we are doing here. I'm having a bad code and I'm turning it into a clean code. Uh, following the best practices to my knowledge, of course. Clean code is an abstract concept, and uh, you should try to do your best, but know that most of the times you probably can do it even better. Every time I write some code and when I open it 6 months later, I see mistakes. I see better I see at least two better ways in which I can rewrite the code. And that's good because I'm developing myself. I'm becoming more advanced. I'm becoming better in terms of coding. So if you open your code which is 6 months old and if you see something that's not quite right, then you're advancing. And even me, who now has 8 or more years of experience with coding, and I always try my best to follow best practices, which I know, I always see mistakes when I open uh, my own legacy code. So think about it. Think about single responsibility. Think about future changes, but not overcomplicating stuff. Think about whether the code is consistent. When you introduce new features, when you write new code, check the old code written for similar functionalities. For example, if you write a new controller class in ASP.NET, check the other controllers, check how they are written. Most developers don't think about that, but that's super important. Check how the old way is done, see whether it has any mistakes in it, and try to be as consistent as possible. The best code, if you are working in a team, the best possible code is if nobody can tell which part of the code is written by whom. So if I open a file and if I recognize that John did it, then there's a very different approaches in which John works and in which, for example, George works. And that's not okay because they don't follow consistent practices. That's super important. Everything should be as consistent as possible. So what are the common code smells? In general, what are the common code smells? First, the first code smell is bloaters. Bloaters means huge classes or huge methods. If a method is, for example, 100 lines of code or 200 lines of code or even 1000 lines of code, there is a huge possibility that something is not quite right in this code because maybe the code is doing too much. Yeah, there are some algorithms out there which need to have a lot of code written in a single method and they are okay, but most of the time that's not the case. So always think about this is getting too huge. I should do something. You should extract classes. You should combine some parameters or variables in a class. You can extract more methods. You can extract classes with methods. You can make the huge method or the class shorter. The second code smell is object orientation abusers. This is the case when you don't use inheritance, composition of the classes, and you use too many conditional statements, switches, type checking. For example, if you find yourself checking for the type of a class, for example, if this animal is cat, do that. If the animal is dog, do something else. That's a very, very wrong example of using object-oriented code. You need to refactor to use inheritance and polymorphism. So object orientation abusers are when you have too much logic and too much if-else checking, when you could replace that with a simple inheritance, for example. Another problem is change preventers. Change preventers are changing one place of one part of the code. If you change it and if you hit compile and see 50 errors, that means that your code has a lot of coupling, a lot of dependencies. That means that you probably didn't design your code very well. So if you change a place of your code and then see that it doesn't compile and you need to change two or three other projects or other classes, then something is not completely okay. And by a change, I don't mean that if you change the name of a function, of course, it will show 50 errors in the places where the function is used. No, that's not the case. I'm talking about that if you change a logic somewhere, and the whole project stops working. The logic stops working. That's a problem. I'm not talking about a simple renaming problem or if you add a parameter to a method and you need to add the same parameter on two, three other places. That's not the case. I'm talking about huge parts of the logic which spans multiple projects and multiple classes. And if you add one feature to the core part of the logic, and if all the other classes start behaving weird, then that's a code smell, that's a violation. The next one is dispensables. Dispensables are commented code or comments which don't bring value, or comments which are pointless, code which is pointless. Uh, Delete that. Delete every single comment which doesn't contribute to the code itself. If I read a code and then understand what it does without a comment above, then I don't need the comment at all. Don't over comment things. That's completely unnecessary. It bloats the code and it makes it more unreadable because people tend to read the comments and then read the code, which essentially loses time. It's important to understand that most of the time developers read code and they write code, for example, only 15 to 20% of their developing time. Most of the time, developers read code rather than writing it. So it's important to write readable code. And if we write readable code, we don't need comments at all. And the last code smell is couplers. We will see an example of this in the project from Microsoft. Once again, it's not their fault. They don't write it with best practices in mind. They write it to validate that ASP.NET Core is working correctly. So we don't blame them. So, the couplers are classes which have excessive coupling and classes which do something that it's not related. We will see that. A shopping cart which knows of the HTTP. In terms of a business shopping cart, imagine you go to a supermarket, you get a shopping cart, and that shopping cart understands HTTP. That's not quite right. Or the shopping cart in the supermarket has database access. It doesn't tick, it's not related. So our code should not relate that too. It's not okay. So if we have a lot of coupling, that means that our code has a lot of change preventers too. All of these are, how to say, they're related. If we have a huge class, chances are that we have object orientation abusers. If we have dispensables, pointless code, comments, and so on, then most probably our classes are bloaters. They are big, they are huge, they are not clean. If we have a lot of coupling, then we're abusing object orientation design. So all of these are connected. And usually when we fix one thing, we fix a lot of code smells at once. Okay, so let's go to the project and take a look at some of the problems. So the project is a typical web application. I have written some tests for it using my test framework. All tests should pass, and I'm going to upload the code on GitHub, and the code will be split with before and after, before and after our change to see the difference. So everything runs fine. Most probably some of these tests will need a bit of refactoring after we change some parts of the code. Of course, we won't be able to change everything, but I'm going to show you all the problems in terms of clean code in the controllers. First things first, we will notice that we don't have a service layer here. We only have a controller layer, and that should be a well-known fact that our business logic should not be in the controllers. It should be extracted to separated services, to an exclusive business layer. That's the preferable approach. And if we take a look at, for example, the store controller, we will see that this is not the case. The store controller directly uses the database and directly makes business logic. Keep in mind that link queries are actual business logic, because link queries are actually for each statements. You say filter by that, select that, order by that. That's a business logic. So when we see a link statement, that means that it is a business logic. Even though it's short, it's still business logic. We are saying we need to get all the genres, include all the albums, and filter them by name. This is actually a business logic. So when you see a link query, that means that it's part of the business logic. It's not the controller's responsibility. So taking a look at this controller right here, we can see that first, the controller doesn't follow single responsibility principles, because a controller's responsibility is to catch the request and provide a response, nothing else. Catch the request and provide the response. It doesn't have to do any other logic. In a perfect scenario, the controller will get the data from the request, will pass it around to other classes which are responsible for the business logic, and then we'll get a result from these classes and return a response. So the whole purpose of a controller is not to have business logic. It's a request to response mediator. That's its purpose. It shouldn't do anything else. It should catch requests, delegate the data from the request to other classes to do their work, to do their tasks, and then from that result, from these classes, it should produce a response. So let's take a look here. First things first, this music store DB context right here is public. Why? Does it need to be public? Probably not. Let's check it out. We can see that it's used only by the store controller. So this is a bad encapsulation. So what we need to do is specify, okay, let's do this. Let's change the class to DB context and rename that. Let's put it like here, and here is the first lesson of clean code. I open the project, and let's say that this project is developed for 3 months, 3 years, sorry. It's developed for 3 years and more. I open it and I start writing in it for the first time. I'm a new developer in the project. And what I can see here is these developers use underscores in front of their fields, even though if I will, as a developer, don't prefer underscores. I need to keep the code consistent, because right now I can say, great, the DB context is done, it's perfect, right this. No, take a note that the other developers use this convention, so we need to follow it. And we need to say, okay, let's add the underscore. Even though we don't like it, we need to keep the code consistent. That's the most important part of clean code. Keep the code consistent, because otherwise, if my team leader goes to the code, he will see, well, that field must have been written by the new developer. It's different from all the others. Then I'm going to add the read-only field, because I see that the other fields also have read-only. So that's important. Something else I need to keep in mind is the ordering of things. I see that the music store DB context is first, and then it's the app settings. So let's reorder that. These small things are important, because small things lead to bigger mistakes. Because imagine the following: if you have small errors in your code, for example, white spaces here and there, people will see that, and they will say, well, this code is not completely clean. Why should I try being clean? There's no point. Why should I try to do my best in terms of clean code? Because it's already bad. Small things lead to bigger. And if we have small mistakes here and there, that will lead to bigger in no time. And if we have a super clean project, when a new developer comes, he will say, wow, there are no white spaces, everything is super clean, super consistent. These guys apparently return code reviews for the smallest details. I should try my best not to have my code returned, because if they return my code during code reviews, they will think that I'm sloppy, they will not give me a raise of my salary, everything like that. So people will see cleaner code and will think, mm, let's try to have more attention to detail, because apparently my colleagues are super clean and super tidy. I don't want to be the bad sheep. I don't want to be the black sheep in the team. That's the thing. So next thing, I see that nobody uses this here. Even though my Visual Studio suggested, and even though I prefer using this, I'm going to say, okay, let's use it their way. Let's make the code consistent. Then here are some of the unnecessary comments. For example, this one. I know how routing works. I use ASP.NET Core all the time. I know that the index page is at /store, the name of the controller. I know that if there is no HTTP post here, the method will be get by default. This code is completely irrelevant. I don't need it. Of course, this comment, and we can see that the code is not consistent because we don't have a comment here. If we open other controllers, we will see that they also have the same comments. I'm not going to fix all of them because we don't want to lose any time, but you get the point. These comments are pointless. I know how routing works. This comment gives me no value. Even if I had an explicit route like this, it's still not worth to add a comment, because I can see that the route is exactly like this. There is no point of having all of these comments here. Let's see some of the comments in the code itself. Retrieve genre and its associated albums from the database. Sure, but I can see that just by looking at this link example. The link example is not complex enough to need a comment above it. I can see that I'm getting older genres and I'm including the albums, and I'm filtering it by name. It's super easy to understand the code. We don't need the extra comment. That's not needed. I see that they're using this here. I need to remove it. I believe Visual Studio added this here. It's not because of them, but I'm not sure. I'm going to remove it because they, I guess, don't use it. Yeah, there is no this here, there is no this here, so they shouldn't use it. Okay, let's return to the store controller. First things first, we have uh, kind of okay controller right now in terms of clean code. Get some data, return it. We can see here that we can fix something. I'm going to add an out album because it's better. I'm going to refactor to use string interpolation. Of course, if the whole code and the consistency of the code says use string format and not string interpolation, then I'm going to return that. So don't use latest features unless all the team members want to use them. So if all the team members use string format, I'm going to use that. Good, I need some formatting here, I guess. Then I can see something like remove from cache if not retrieved in last 10 minutes. I can see that. I can see the sliding expiration is for 10 minutes. That comment is also irrelevant. I can see that this is getting too long. This is this is one of these examples I said, hey, if something is too long, introduce something else. If this method is too long, introduce a separate method. If this declaration is too long, introduce something. So I can see that this is taking quite a lot of code for a single expression, because that's a single expression. So what I can do is I can introduce a variable, and I'm going to say, okay, var cache options equal to this. And I'm going to fix it. And I can even set it like this, and I'm going to specify cache options. This is much cleaner, much clearer. Good. The next thing about this controller, and wait a bit, by far this may be a little bit boring, or you may know this, of course, but wait to see the shopping cart, the implementation of the shopping cart. That's a huge violation there. There's a huge violation there. But we need to start from the small things. Okay, so extracting variables. Even a variable can improve the code. The code is much more readable now rather than when it was here. Good. In terms of cleaning the small things in this controller, we did a pretty good job. We encapsulated some fields, we removed some unnecessary comments, we removed some bad practices in terms of this and so on. But let's think about something else. Is this controller doing a single thing? Yes or no? Apparently no, because the controller has more than one responsibility. It has business logic in terms of link expressions. It has request response delegation. So currently the controller is doing everything, and it accesses the database. Uh, it has business logic in it, and it's doing request response. So this is a violation. The solution here is to introduce a service. I've already done that multiple times. Watch my how to write testable code on my YouTube channel. Watch that video series. I extract a lot of services there. If we have time, we're going to extract some of this logic, but know this. This is business logic. This should be extracted to a service. We should have a service layer, services. I'm not going to extract everything because it will take a lot of time. You should know that. Most people teach that way when they teach ASP.NET Core. And I should say genre service. And I should say public interface genre service. I should say something like, let's open the store controller. Something like Uh, Find by name with albums. And this should return genre, which is another problem. But let's start it small. Find by name with albums. Or even better, we can say it something like this to make it more generic. String genre include albums equals false. A default parameter. Then I need to say, okay, let's add genre service. Let's add the DB context, which is music store, I believe. Music store context. And I'm going to take a look at how other people in my team are naming the context. And apparently it's DB context with an underscore. So I'm going to keep that convention. Then I'm going to initialize it from a constructor. I'm going to use expression bodied members, but if the team doesn't want to use expression bodied members, I'm not going to use it. So that's important. It's important to understand that whether the team is using a certain C# feature or not. That's super important. That's one of the most important parts of writing clean code. Good. And then I'm going to say I genre service. I'm going to implement the code. I'm going to get the logic. I'm going to say, okay, this should be an async task, apparently. I'm going to write task like this here too. And I'm going to extract that. I'm going to say var query equals that. Then I'm going to say if include albums query equals query include albums. And I'm going to say return await query first or default async like this. So we made a clean method, a method which does only the business logic, and we made it more abstract because we can now use this method to include the albums or not include them. So apparently we made a more reusable piece of code because when I search for genre, I can search it without the albums and I can search it with the albums with a simple parameter. I see that there is a white space here. I need to fix it. Okay, so this is a single responsibility method. Uh, it just makes part of the business logic works and nothing else. And also this code right here is completely reusable. And in the store controller, instead of music store DB context, I need to inject iGenera service. This should be well known by now by you, but nevertheless we need to cover it and let's say true. I'm going to say await. And now this method is super clean because what it does is it gets a request from the browser, it delegates the request to another class because the controller's responsibility is not processing business logic, and then returns a response based on the result. Super clean. What's next in terms of that? Well, we need to refactor this, we need to refactor this, we need to extract everything to a service and then remove the music store DB context. It's not a controller's responsibility to make database calls. That's not its job. That's just ridiculous. So that's one of the things. Second, if I see a lot of things going on, for example, if genres equals no, return not found, something like that. If I see a lot of code repeating itself like this is essentially the same code, but with different parameters. I need to think in a way to extract that. So how to do it? I can extract a controller extension, return view or not found, and my code will become return view or not found genres. So I need to extract everything that repeats. Even though it repeats with parameters, I need to extract it because it will be cleaner and shorter. I don't need to read this if check. It makes the code look a little bit more complex. Of course, this if check is super beginner friendly, but it doesn't matter. We may have more complex checks here. So we should always think how to extract the same type of code. For example, here it is again. If genre model. So what to do in this case? Extract something. Extract. We can see that it's a copy pasted piece of code, but instead of genre it says album. So what to do here is introduce infrastructure, introduce extension methods, extract it somewhere, controller extensions, and make an extension method and say public static controller extensions, public iAction result, view or not found, and say extend the controller object with the model and extract that. Extract. When you see something that is copy paste, just extract it. Public static controller.not found, controller.view with the model. Done. And now we can improve our code by saying return this dot view or not found with album. Done. I'm using this here because for extension methods I need to use them. It's required by the C# code, so I'm going to use it even though nobody uses this in this project. So this is improved. Then improve this. Done. And all of a sudden our code became cleaner, shorter, cleaner, and it doesn't do a lot of stuff. Next, what will happen when we start having a lot of services here? Of course, I need to register the service, so let's go and add it. Services, add transient genre service. Let's see whether we broke something. That's what unit tests are for, after all. Everything is fine. Good. So what are next things to improve? Well, we will have a lot of services here. always think it like that. If we have a lot of stuff somewhere, a lot of classes in a folder, a lot of methods in a class, a lot of variables in a method, a lot of stuff somewhere, extract it, introduce something else. That's a super important part of clean code. So if we happen to have a lot of services, and we will when the project grows, then go and introduce folders and add these two things there. Improve the namespaces, this and like this, and good. So always think how to extract. Always think when you have repetitive tasks, think how to improve them. For example, when we have a lot of services, the startup class will start growing and it will grow a lot. So that's not very convenient. Extract that to a method, first solution. Extract application services to a method. That's the first solution. Or introduce a reflection-based convention. But let's see one more mistake here. And the mistake is well known among the C# developers, but let's see why that mistake is actually a mistake. So what we do here is we get the genre, which is a data model. This is used by the database. This is used by the entity framework and for all the link queries. And we use that model, the same model, to we use the same model to visualize stuff. So is the class genre having the single responsibility principle? Nope, because it's used for the database and it's used for visualization. So in terms of uh, solid, even this simple class is wrong. It's just wrong. This is not correct. It uses too much stuff. It is used by too much stuff. So we need to refactor that. Most developers know that they need to use a view model here. They know that. For example, the ASP.NET team made a view model for that and view model for that. They made a manage view model. They made an error view model, and that's great. But they didn't make for the genre. They didn't make for the album. And we need to do it. This is why people make view models. You may know that you need to do a view model, but you may don't know why. Well, single responsibility. Besides some other mistakes you may do. For example, some parameter tampering hacks and other things you don't want to get yourself into. But let's take a look in the album class, because while we're talking about models and view models, this album class makes, even though it's kind of simple to do, temporary hack. Well, this comment should be it's necessary, because otherwise we won't understand why this constructor is right here. So this comment is necessary. Of course, there's a mistake here, but nevertheless, because otherwise somebody will say, well, that's not needed. Let's delete it. Let's remove it, because people will not understand that this is some sort of a hack. So this comment is relevant. Spaces between properties, that's also a thing. But nevertheless, what does this album class do? Well, first, it's part of the model binding. Second, it's part of entity framework. Third, it's part of visualization. So this class does three things: model binding, visualization, and database operations. So single responsibility, no. And even though it's super simple, it's violating the solid principles. And we can see it from the attributes. Required string length, that's both database and visualization. data type, that's visualization, display, that's visualization, bind never, that's model binding. So the class is doing too many things. In the perfect scenario, you know, I guess, if you watch the Write Testable Code series, you will see a lot of examples. So that's why I'm not implementing them. But we can see uh, we need a database model, a business logic model for the service layer, and visualization model. And the business logic model, you may name it service model, the visualization may be view model. You need form models for model binding, so that's input models, and so on and so on. So you create a separate class for each responsibility, and that's important. Because what will happen here is somebody will come and say, well, I need to visualize something, new visualization. And he will not understand that Entity Framework will start using this property for a database column. He will not think about that. He will not understand that because he is thinking about the views. He is thinking about the HTML. So he will see the class and say, oh, that's the visualization class. Super. I'm going to add a new property. And this property start is now used by the model binder. So people will be able to inject here some hacked data, and and the entity framework will start thinking about this property as a database column. So for not having single responsibility principle here, we may introduce bugs very easily. Good, enough with that. Let's see something else, because the store controller, it can be improved, of course. We can extract this to a separate logic. We can extract this to a caching service. Just like we have a jar service, we may add a caching service. But for now, let's do that. Then we have a startup class. The startup class, is it doing a lot of stuff? It's a bloated class for sure. It has like 200 lines of code, but let's see why it's violating clean code. Because we have first configuration building, the one responsibility. Second, configuration of databases, configuration of course policies, configurations of adding services, that's for responsibility, configuration of authorization policies, authentication keys, some code comments again, specifying middlewares. So the startup class should register services in that so. So all of these should be extracted. Services configure app settings, that should be extracted. Services add DB context with SQL Server. This is database configuration. It's not service registration. We have add authorization. We have add authentication. It configures a lot of stuff. A better approach, if we go to my GitHub profile. Let me find microservices applications. Let's check a startup class here. Super clean. 37 lines of code. Everything is extracted. Register web services, register data seeder, register statistics service. Super short and clean. And when we go to add web service, let's find that. Add web service, add web service, add web service. Here it is. We will see that it has add database, add application, add token, add controllers. Super clean again. So essentially what I did with a startup class which looks like this is I extracted a lot of responsibilities from it. I removed a lot of stuff. And usually you extract it as an extension method, like we did with the controller earlier. So then we have a database method, which configures the database. We have application settings method. We have the authentication method. Here it is, the authentication, a token authentication. This configures the authentication. So everything is nice and clean. Everything is extracted. So the startup class is not using a lot of responsibilities. It just registers services. It says we need services for the web server, we need services for the database, we need services for the authentication. That's it. And this class, like right here, it registers routes that should be extracted. It registers, initializes the database. That's also a responsibility for another class, and this, I would say that it's huge, but it's filled with fake data, so it's okay. Even though, if we want to improve this class, this fake data should come from an Excel file or a text file or comma-separated values, whatever. This is too much hard-coded strings. Nevertheless, too many hard-coded strings. Nevertheless, I believe you understood that the class is doing a lot of stuff and it's bloated. It's having too much. For example, here is another comment. Add identity services to the service container. If I remove the comment, I will understand that I add to the service container the identity services. So the comment is not needed too. It's too much. Okay, so we're not going to refactor the startup class because that will take us a lot of time. But let's take a look at another controller. This one should be a little bit better. Of course, these usings should be here. So we should have music store infrastructure, services, and genre, like this. Because the whole project uses usings outside of the namespace, so we need to follow that. I prefer to have them in the namespace, but it's not my it's not me to decide that. It's already decided from the other developers. Okay, let's see another violation. Let's go to the checkout controller, for example. The checkout controller, we will see again comment, comment. We will see a lot of code here, business logic, reading a form from the request instead of a model. That's not by convention. We need to read it from the model. We need to model bind it. That's a mistake. We'll see that we have the username provider of the system goes directly to the HTTP context like this. So this will be part of a lot of controllers. So what we need to do is we need to add a current user service. So I need to go and say iCurrent user service because it's not a responsibility of the controller to extract the user properties. iCurrent user, and I should say user ID like this. And I should use the service. Let me implement it. Not current, it should be current user. I should create private read-only IHTTP context accessor. this, and we may say it and remove the this because the project doesn't use it. So now we have a current user service, and the checkout controller will no longer, and all controllers will no longer need to access it like this. It will be way easier to test because this right here is more difficult to test. So to make the code testable, what we did is we set a current user service, and it will be super easy to mock and change the user ID. So the important part here is the controller doesn't need to know the logic behind getting the username. The controller needs to get the username right away. It's not his responsibility to extract usernames, even though it's a single line of code. That's a separate responsibility. That's why we introduce current user service. And of course, we need to inject it and reuse it and so on. Good, so a lot of things are going on here. Look, comment. I'm not going to check every single comment, but a lot of the commenting is unnecessary. Add the order, process the order. It's save changes. It's it's self-explanatory. Good. If we take a look at the other parts of the controllers, we will see the same thing. We will see again business logic, more business logic. This should be in a separate cache service. They do a lot of logging around here. For example, logger. This should be extracted as an action filter. Just extract it as an action filter. Also, try catch. If it's possible, don't use try catch. Use control flow. Use if else. Try catch should be completely exceptional. Completely exceptional. Good, but let's see one more thing. Let's go to the shopping cart and see how the shopping cart is implemented, because that's a huge violation of the solid principles. Take a look at it. The shopping cart is a static class which needs the DB context and the HTTP context, talking about coupling. Do you know a shopping cart in the real world which knows about databases and knows about HTTP? Yes, no? No. Not to talk about the static class. Static is not testable at all, so it's considered a bad practice if it's not a pure function. If it's a pure function, it's okay. But this is not a pure function. This has state. It has state, and the state comes from the HTTP session. So apparently, that's also a violation. But other thing to note here is the shopping cart knows about the database and the HTTP context, which is not very convenient. What we need to do here is we need to separate these concepts. The first thing is we need to have a service which works with the music store context, with the database, which communicates with the actual database to retrieve items. Then we need to have a shopping cart, an actual shopping cart class, which will perform the logic. Add a cart item with the album ID and so on. Remove from cart, for example, this one here. empty car. So apparently that's a pretty coupled class. With music store DB context, it has HTTP context here. It's not written very well. It's not clean at all. So what we need to do is we need to have a shopping cart provider first, which will store the shopping cart in the session. So I'm going to add new class my shopping cart provider, which will have get which will have get current or string, because we need to get the shopping cart ID, get current cart. That's it. Super clean and super simple. It's more testable than the current static approach. Then I'm going to add, let's move that to a shopping cart. Add that here. You need to understand why we're doing that. The most important thing is the shopping cart is having coupling with the database and the HTTP context. That's a lot of coupling. The database and the HTTP are in the same place. If we have a typical three-layer architecture, database, business logic services, and presentation, we have a mix of all. We have a database layer mixed with business logic, mixed with this here. And that means we need to extract this. So shopping cart provider, this will be the HTTP part of the class. So let's create add new class shopping cart provider, sorry. Shopping cart provider, shopping cart provider, get current cart. So the shopping cart needs an HTTP context, so this is apparently the whole logic I need right here. And let's import the GUID. Let's say private read only HTTP context. HTTP context. These comments are unnecessary. Then I need to say public shopping cart provider HTTP context accessor, HTTP context accessor, this HTTP context. Let's remove the this and add the underscore. Let's make the code consistent and follow best practices for the project. HTTP context equals HTTP context like this. Second thing, we repeat ourselves. That's copy-pasted code. Extract a constant. Private const string shopping cart session key. And use that here. Super cleaner. Because this class now has a single responsibility to retrieve the shopping cart from the current session. That's the whole point of this class right here. Good. So instead of using instead of using this method, which is used right here, public static, we now have a shopping cart provider. I'm not going to delete this code because it is still used here and there, but I'm going to start refactoring the controller. Let's go to the store controller. No, it's not, it's checkout controller. No, shopping cart controller, this one. So get cart. The cart returns a shopping cart class. The shopping cart class currently has a lot of things. It has database, the shopping cart ID, it has business logic, it has a lot of stuff. So let's go here and say var cart ID is, let's inject a shopping cart provider, let's introduce that, add an underscore, this should be private too, like we said. Remove that, put it here, and add a read only. Done. So var cart ID is shopping cart provider get current cart. Done. We now have the cart ID. Then we are going to introduce a service which will use the database. Shopping cart service, which will have the business logic. Add new class shopping cart service. Go to the shopping cart controller, get cart. We need to have get cart items and get total. So these are the two methods I'm going to move to the shopping cart service. This one. So I need create field DB context, music store context. Let's make it read only. Let's introduce that from good. So this class now only does business logic with the database, and everything it needs is from the outside. This class is super clean because it says I need the cart ID to make my logic. Give me the cart ID. It's not a responsibility of this class to get the cart ID directly. It's not a responsibility of this class to get the HTTP session. This is pure database link queries. So get cart items. We go back to shopping cart controller and we now are going to introduce a shopping cart service. Shopping cart service. Let's introduce that. Nope. And we are now going to say await this shopping cart service dot, well, I need some methods extracted here, like this. Could be an interface. Done. Shopping cart controller, get cart items with the cart ID. We can even say that this is not a service. We may say that this is the shopping cart directly. It depends on the naming convention. Let's say that all services in our project should be suffixed with the service suffix. So let's name it like this. Then get total, the same thing. Multiply album price by count of that album to get the current price for each of those albums in the cart. Yeah, that comment is kind of nice because at first when I say select album price multiplied by count, I may not get the whole idea. I may not understand the calculation, but the comment is helpful, so this comment is good enough. It says calculate the total price in the shopping cart. Oh yeah, I don't have to think about the formula here. So let's move that to the shopping cart service too. And again, string ID. Something else we can do here, because we start to notice a pattern. Every time we use the shopping cart, we need the shopping cart ID. Create order is get cart item shopping cart ID, shopping cart ID, shopping cart ID. Well, what we can do is we can say good, besides the music store context, I want to have the shopping cart provider too, shopping cart provider. And now you may say, but what's the difference? How come this class uses the provider? How come this class uses the provider even though the provider is from the HTTP, from the session? Well, it's different because this is an abstract concept. This doesn't tell anything. This doesn't tell, hey, I'm coming from HTTP. It tells this abstract concept provides your shopping cart, and it's easily testable and super clean because we don't care how the shopping cart is provided. We care that it is provided. And that's super convenient. It's way better than depending on the HTTP context directly, like this. It's it's huge coupling. We depend on a class. This is a business logic class, and it depends on a web framework class. This is from the web framework. It's in ASP.NET Core HTTP. Super coupled. And the provider, the interface, is just an interface. It doesn't depend on anything. What's the dependency here? Nothing. And that's cleaning the code. That's actually cleaner code. Coming back to the shopping cart, and now what I'm going to do, okay, let's remove the provider from here. I don't need it. I'm going to use it directly in the shopping cart service. Coming here, removing that, and in the shopping cart service, I'm going to say remove that, and I can even say string shopping cart like this, and I'm going to say shopping cart equals shopping cart provider get current cart. Super clean, way more cleaner than before. And now done. And I'm going to remove that as well, and I'm going to say done. Let's move that to the shopping cart service like this. Let's go to the checkout controller No, not check out the shopping cart controller. And let's say that we want to have shopping cart service get total like this. And now the static shopping cart is no longer needed. This comment too. This comment too. Creating a new a view model. Set up our view model. I can see that. Return the view. I can see that. I can see also that. So now this method no longer depends on a static class and it's super clean. We extracted the shopping cart and made it way more cleaner. And why don't I inject the IHTP context right here? Why I don't inject that? Because the IHTP context is also an abstract concept. Yeah, but it's bound to the web. HTTP is web. This is business logic. The business logic should not depend on the web. My architecture goes from the database, service, and the presentation layer, and it goes like this. The presentation depends on the service depends on the database, and not the other way around. So apparently I don't want to inject the HTTP here because that's a concept from the web. I want to have only business related stuff in the service here. That's the important part. Separation of the responsibilities. First responsibility, get the shopping cart. Since it's coming from the HTTP, I extract it. I put it behind an interface, an abstract concept. So the business service no longer knows about HTTP. Then the business logic of the shopping cart, okay, introduce a new uh, better service, shopping cart service. And this way I improved this method here because I have mixed responsibilities. So we saw a lot of code smells. We saw a bloated class, the startup class, one of the controllers. Too many conditionals is, we can see that in the checkout controller, this thing here. That's way too much code. Form collection, try catch, if, get the username, do a database operation, get the shopping cart by providing an HTTP context. That's super coupled. Super coupled. I'm going to leave you uh, this method as an exercise. The address and payment method in the checkout controller. Try to refactor it yourself the way I am refactoring the shopping cart right now and give it to me. Just try it and try to do your best here. Try to make it as clean as possible and give it to me. And I'm going to tell you if you have mistakes or if you did a good job. So I'm going to make a code review. A lot of stuff is going on here, so it will be a huge exercise for you. If you're new to clean code, of course. So try it out. Try it. Try to extract everything you can here. Try to separate the different responsibilities. Try to understand how this thing works. There is a unit test about it, so you have an assertion to see whether the logic is still there. So check it out. Try it. And give it to me, and I'm going to review it. It's a good exercise. It's similar to the thing I'm doing right here. The shopping cart controller, I'm extracting responsibilities away. So we can see that the controller responsibility here is only prepare a result. Get a result from some other class which is responsible for the shopping cart, and then return a response. All the methods should look like this. Good. Let's... If I run the tests now, they should fail because I never registered the shopping cart services, but let's try it. Yep, failing. Pipeline, shopping cart. unable to resolve service of type. So let's fix that. Let's go to the startup. Let's go and add I shopping cart provider mapped to shopping cart provider. I shopping cart service mapped to shopping cart service. And I can see that I'm violating the single responsibility here because this class starting doing too much. So what I can do is go to the infrastructure, add class service collection extensions and clean it a bit. Static public static iService collection, add application services or business services or whatever. Business services, this iService collection, and I'm going to say services, add this. And done. Good. And now add business services. Startup, add business services. Or application services or whatever, but it gets the startup class cleaner. Of course, it needs a lot of work to become as clean as possible, but nevertheless, I can see that the namespaces are inside, and they are not correct in terms of our convention, so I changed that too. Okay, let's run the code again and see what will happen. We made a lot of changes. Everything is fine. So great, my refactoring is working out. Oh, it worked out correctly. So here I need to introduce, first remove the white space, but I need to introduce, let's see, I need to have add to cart method to the shopping cart service, added album, for example this one, which of course what it does. Let's copy that to our new service, shopping cart service. And let's see what to improve. Get the matching cart and album instances. Okay. This gets this gets the current shopping cart. If it's not no, add the new cart item with the album. Do I need, here is something else here. Here is another thing. I'm passing the whole album, but do I need it? This class now has a responsibility for the album. It has a coupling to the album. But do I need that? Because I need only the album ID. So why don't I change the album ID like this? And now the class is cleaner because it doesn't have access to more things than it needs to. It has less coupling to the whole class. It only needs one single variable. So we improve that. Let's go to the shopping cart service here. And let's go to the shopping cart controller and say retrieve the album. Yeah, sure. Okay. Then what we need to do is shopping cart service add to cart album ID. Added album, not album ID, like this. And we need to await that. Good, so we no longer need that. We no longer need that. The save changes async should be in the add to cart itself, because we are saying add to cart. That should be a solid transactional operation. So we're going to say here await db context save changes async without this, because I like this, but again, because we need to be consistent. So what we did here is we moved the responsibility to the add to cart method, because that method on itself doesn't do anything. It gets a shopping cart, adds something, but nobody saves the changes. So the responsibility of saving the changes was outside of the method. So the method was coupled to something from the outside to work correctly. That's also not okay. The whole method needs to be cohesive and it needs to do everything by itself. It needs to do the whole business operation, because otherwise the responsibility of storing albums in the shopping cart are spread throughout different classes. And this responsibility should be right here in the business logic. So let's go to the store controller, to the shopping cart service, shopping cart controller. So we no longer need that. Did save changes. And we need to extract that, and we can even optimize. Let's say it like this, because we only need the album ID, we don't need the whole album. So let's optimize the database call, because that's also a problem here. I'm going to say album dot album equals ID, select album ID, and single async like this. We can even send the request aborted here. So the added album is now album ID, and we can just provide it here. By cleaning the code, we also optimized. The we optimized the performance of the database. We don't no longer fetch the whole album, just the ID. And we fixed the bug in the logger because there was a missing $sign here. Remove that comment, it's no longer needed. This logger, it's better to be in a filter. It shouldn't be scattered around the whole business logic, controller logic, and so on. We can add it to a filter and log before the action, log after the action, catch all exceptions, and log them. If you don't understand the concept, let me know and I'm going to show you how it's done. How to abstract the whole logging from your application. Of course, this should be extracted to our albums service as well, the same way we did with iGenre service, but I'm not going to do it right now. But if we extract it, this method will again become super clean. Let's run all the tests again to see whether this is still working. Everything is fine. You may try to finish the whole project and, for example, extract this too. Get the cart, retrieve the cart, remove item from cart. All of these should be extracted to services. because of the single responsibility and the boundaries of the classes and cleaning the code. Okay, let me finish with extracting the album ID because otherwise I would need to leave the method in a bad shape and I don't like that. So album, albums because genres. So we follow some sort of a plural form here. Shopping carts, maybe, not sure. Shopping cart is a single entity in the site. We don't have multiple shopping carts, but mm, you need to consider the naming of this folder with your teammates. I believe it should be shopping cart, but all the others should be in plural form because we have models, services, scripts, and so on. So one last interface, album service, uh, hmm, I just thought that we receive the ID, then we check the ID, then select it. But we have the ID. So this shouldn't be done. That's not this database operation is unnecessary. It should be like this: any var album exists. Any album.album ID equals ID. If album does not exist, return bad request, and that's it. Any async, of course. That should be the logic here. We don't need to pass. We don't need to make a super complicated logic. So let's extract that to iAlbum service and say task bow exists int album ID. Let's add an album service. I need this album service. Go to the shopping cart controller and put the logic here like this. So album ID, I'm going to remove the cancellation token, but if you want to support cancellation tokens, leave it, it's completely okay. So I need to register the service. And finally, I need to fix my controller, which doesn't have a good separation of concerns. Album service, introduce the field, and say album service exists ID. Oh wait, done. Let's run all the tests, but we made the code cleaner because the code now has single responsibility if we don't count the logger here. Last, I can add filters, and I can say add new class logging filter. I can say action filter attribute, and I can override on action executed and on action executing. We can also override the async version, but public override on action executed. I'm going to show you the main concept behind logging generally in your application. And we can say we can inject private I logger log filter attribute, inject it here. I'm not sure whether the construction injection will work, but we can get a request services, get service, iLogger. I need to test it. I need to and I can log whatever I like. Log information, and I can say context, controller, not controller, route data, action, for example. I can get what's wrong with you? Values action, and so on. I can log everything I like. I can log the request ID, the request data, the response data, and I can do the same on public override void on action executing, and I can do the same thing here. I can say, okay, I want to log the following, execute it with the data, with everything, with the request, with the response, with whatever I like. And here I can specify action started, and again I can specify whatever you like. Action finished, and then the walk filter attribute, I can register it globally. I can go and say add MVC options, enable endpoint routing options, filters, add walk filter attribute, done. And from now on everything will be locked the way I want it. So the checkout, the shopping cart controller no longer need to lock this, because I can see that if the action finished successfully, this ID was added to the cart because of the filter. Of course, I'll need to add more information here. For example, get the exception. For example, validate the root, not validate, but extract root values, root data, model binding data, everything I actually want to log. But we can extract everything. This context class has a lot of stuff. Action arguments, the controller, the result, uh, the whole action, the current HTTP context, the model state, the root data, a lot of stuff. You have a lot of stuff to work with, so you can extract the logging in a log filter. And this will make your code clean and cleaner. So look how cleaner it got. Check the album. If it doesn't exist, bad request. Or not found. Whatever. Super clean. This was bad, this was bad, and now it's super clean. We extracted all the responsibilities to separate classes. That was the important part. So guys, I hope you learned how to extract things, how to work with cleaner code, what to do with the code, how to make it better. Always think about, is this code is doing too much? Is this code is coupled with something? Is this code is having too much logic? Always think about that, because we saw bloated classes, we saw, this should be outside. We saw bloated classes, we saw couplings. Think how the shopping cart service doesn't have to know with the HTTP service. We have separations. We have the database separation, we have the service layer separation, and the web project separation. So the shopping cart doesn't have to know about HTTP or the database in that matter. It doesn't need to be a static class and so on. So we improve the code quite a lot. And everything should compile and run successfully. There's an error here. Yeah, okay, I need to fix my test because I removed the cancellation code. I need to remove that one too. Good, let's run it again. So guys, I'm going to commit the code now. I showed you all the main principles of the clean code. Oh. Parameter logger. Value cannot be no. Yeah, I guess this logger needs more work, of course. It was just an example. Done. But this is the idea behind the logger attribute. You need to make it you need to implement it by yourself, because I didn't make a production ready logger. But injecting iLogger of something and logging. iLogger of iApplication, iLogger of controller, iLogger, it doesn't matter. You can inject whatever you like here in the filter. Good, so I hope you understood the concept, why I extract things, why I do it, what I'm after when I do certain operations in the code. This is a smaller project, and I'm going to make a similar video about a bigger project, a real life project, to show you where clean code is violated, to see even more examples. But the whole idea is think about whether a class, a component, a function, a variable is doing one thing and one thing only, and think about the coupling between your classes. If the coupling is on interfaces, that's not a coupling. You can easily change it like this. The shopping cart service wants to have a shopping cart provider. It doesn't matter. It's abstract enough. But know that the music store context is super abstract too. That's an abstraction over the database. This is why I don't add a repository, an interface, and so on. You don't need it. This class here is super abstract, and you can change it whatever you like during the runtime. You can change it in your tests. You can do whatever you like. As you can see, my tests are using an in-memory database, and the Rio app is using a SQL Server, but that doesn't matter. I can test that class, so I don't need an interface. Good. Try to refactor some of this code here. Try to refactor the longer methods. For example, the address and payments. Try to refactor the remove from cart exercise. Try to clean the code and then send it to me, and I'm going to review it. Okay guys, that was it for this video. I hope you liked it. I hope you understood the whole concept of the clean code, and I'm going to see you in my next videos, which are going to be released this month. They will be again about clean code and solid, but in a bigger application, in bigger project. This was just for a warm-up. Bye.